Okay, here I want to show you the construction of an epicycloid. The construction of an epicycloid. Whenever you are asked to construct an epicycloid, two things will be given to you. The first is the radius of the base circle. The radius of the base circle. And the second is the radius of the rolling circle. The radius of the rolling circle. So once those two things are given to you, you can go on and construct the epicycloid as I'm going to show you here. Now, the construction is as follows. The first thing is for you to locate a point on your paper, and that is what I've done here. This is the point, and I call it point O. Now, the second thing that you need to do is to add the radius of the base circle and the diameter of the rolling circle. You add them together. Here, the radius of the rolling circle that we are using is 20 mm, and the radius of the base circle is 75 mm. It means that the diameter of the rolling circle is 40 mm, and 40 plus 75 will give us 115 mm. So from point O, take a measurement of 115 up here and draw line OA, which I have done here. This is line OA. This vertical line here is line OA. Then from this point here, take 20 down. Take 20 down here. Okay. So after you have taken that 20 mm down, then draw this horizontal line here. This horizontal line, which is equal to the diameter of the rolling circle, 40 mm. Then put your compass at the point of intersection of this vertical line and the horizontal line. Then draw a circle. Draw a circle radius 20 mm. Then divide the circle into 12 equal parts. I have done it here. Okay. So the next thing that you need to do is to calculate an angle. Calculate an angle, and that angle is the angle between line OA and line OB. The angle between line OA and line OB, this is the angle, this angle here. I mean this angle. This angle here. Okay, so you need to calculate this angle before you can draw line OB. Before you can draw line OB, you have to calculate the angle, and the angle is gotten by dividing the radius of rolling circle by the radius of the base circle, multiply the result by 360 degrees, which I have done here, and what I got approximately is 96 degrees. The angle is 96 degrees. So take 96 degrees on, use your protractor. Use your protractor, set your protractor on this point as I've done here. This is it. Okay. And look for where you have 96 on your protractor. So this is 96. So, and I've drawn the line. So the line also is equal to 115 mm. Line OB is equal to 115 mm. Okay. So after you have done this point here, this point from here to here, from point O to PO or P0 is 75 mm, which is the radius of the base circle. So I'm going to draw the base circle now by taking my compass, put the pinpoint at point O and extend it to point P0 here. Extend it to point P0, and I will draw the base circle. I will draw the, so this is it. Okay, so this is the base circle here. This is how it will look. We will call it diameter of the base circle. So this is it. Okay, so after doing this, the next thing I'm going to do is to number these points on the circle. So the circle is rolling in this direction, is going in this direction. So mean that this is point 1 if this is 0. So here is 1, here is 2, here is 3, here is 4, this is 5, so this is 6, this is 7, this is 8, this is 9, and this is 10, this is 11. So point P0 makes it 12. Point P0 makes it 12. So the next thing that you are going to do is that take your compass, put your compass at point O here, extend it to point 1 here on the circle, extend it to point 1 on the circle. Point 1 and point 11, they are the same distance on the circle. So you draw an arc like this. So draw an arc. So when you touch line OB, stop it there. So the next is 2, 10. Point 2 and 10 on the circle are the same point on the circle. So, and you draw an arc. Draw an arc like this. So when you touch line OB, stop it there. So next is 3 and 9. 3 and 9. Okay, there is something I'm going to say about this point 3 and 9. Okay, so 3 and 9, then so you draw an arc like this. Then put your compass at the center of the circle here, at the center of the circle. So this arc that I want to draw by extending my compass to the center of the circle is called the locus. So that's what we are going to use to get this epicycloid that you want to construct. So you need to draw this. This is very, very important. Okay. So next is extend your compass to 4, 8. So point 4 and 8, they are the same point on the circle. They are the same distance on the circle. So draw an arc. So when you touch line OB, so you stop it there. Then move to point 5 and 7. They are the same point or distance on the circle. So draw an arc like this. So when you touch line OB, stop it there. So the last one is point 6 on the circle. So draw an arc like this. Okay. Okay, so the next thing that we are going to do, so label this point. This is point P0. So come to this point also here and call this P0. Call this P0. So this is P0. So this arc P0, P0, this arc here, which is for the base circle, we are going to divide it into 12 equal parts. So we have to divide into 12 equal parts. Don't forget that this angle here, this angle OPO, PO here is, or angle PO or P0 OP0 is 96 degrees. So 96 by 12 will give us 8 mm, to give us 8. So set your protractor at this point O like this. Okay, so set it here and take 88 mm. 88 mm. So this is the first 8. Just be putting a dot or dot on the paper. So this is the first 8. Next is 16. Next is 24. Next is 32. Next is 40. Next is 48. Next is 56. Next is 64. Next is 72. So 72. So next is 80. Next one is 88. Okay, so the rest is equal to 8. So from each of these points, you may not be able to see the point, but if you follow what I said, you will get it. So from this point O, so draw lines through each of these points. So this is what I'm saying. So next, okay, so just continue like that. So I'm going to pause the video and we'll continue from there. Okay, so for me here, I have drawn all the lines from point 0 passing through each point of the division, and it stops on this arc 6 here. Okay, so the next thing that I've done here is that, don't forget I said that we have to draw an arc from the center of the circle, and that arc that starts from this point here and hence here is known as locus. So it's very, very important. So where this line that I drew out from point 0 or point O here touch the locus, I've labeled them, and I call this is this center here. The center of the circle is C0. Here is C1, C2, C3, C4, C5, C6, C7, C8, C9, C10, C11, and back to C0. So where each lines that we draw out of this point touch the locus. Okay, so the next thing that we are going to do is that take your compass and take the measurements of the circle. The measurement of the radius of the rolling circle. Take the radius of the rolling circle. So I'm doing there. So take the radius of the rolling circle. So put it at point 1 here. This is point 1 or center 1. This is center 1 here. So put it at center 1, and you look at arc 111. This is arc 111. So, and you draw an arc here. This point. So this is the first point. Okay, so this point here. Then you put it at center 2 here, and on line 210, so you draw an arc here on this arc here. Then put it at center 3 here. Put it at center 3, and so you draw an arc on arc 3 9. So cut it here. Okay, then put it at center 4. So this is center 4. So on the arc 4-8, so you draw an arc here. So this is it. Then put it at center 5. At center 5, so arc 5-7. So it cut it here. Cut it here. Then put it at center 6. Okay, so it will touch this point here. Touch this point here. Okay, so next put it at center 7 on the locus. Then you make an arc here on arc 5-7. So it cut it here. So put it at center 8. So arc 4-8. So you touch it here. Okay, so put it at center 9. So this is center 9. And so you make an arc here on this arc 3-9. Arc 3-9. Then put it at center 10. So make an arc here on 210. Then put it at center 11. Center 11. So you have an arc here. So these are the points that we are going to join together. So here we have this point. So let me start from here. So here we have this point here. We have this point. So I will call this. So this is P1. This is P1. This point here, this is P2. So here we have this point. So this is P3. And then we have this point. This is P4. So here we have this point. So this is P5. And then we have this point here. So this is P6. Here we have this point. This is P7. So this is P8. So here we have this point. So this is P9. So we have this point. This is P10. And here we have P11. Okay, so we already have P0 here. Alright, so the next thing that we are going to do is to use our French curve to join the points together. So starting from here. So starting from here. And join these 4 points together. Okay, then can join these 3 points. Okay, I should take it to 2. So joining these together, then and join these together. Okay, so next turn it here. Okay, these 4 points can be joined. Alright, so the last one is this. Okay, so this curve that we have produced here is known as Epicycloid. Is known as Epicycloid. This is known as Epicycloid. This is the base circle, diameter of base circle, and this is the rolling circle. So when this circle is rolling on this arc, of the base circle. This is the shape that will be formed. So if I'm to label each point, I'm going to have something like this. I'm going to have something like this. This is it. Okay, so this is it. This is what I will get. So this is the rolling circle. This is the epicycloid. This is the base circle. And R is the radius of the base circle. Capital letter R is the radius of the base circle. Small letter r is the radius of the rolling circle. And the angle between this line and this line is equal to theta, or is theta equals radius of the rolling circle divided by the radius of the base circle and multiply the result by 360 degrees. It will give you this angle. So the construction of an epicycloid is as simple as I've explained here. So all you need to do is to practice. So once you practice, you will master it. You will master it. So keep watching my videos on YouTube and keep on practicing. I so much appreciate you. Don't forget, like the channel and share my videos with friends who are technical drawing students. Thank you.